Evaluating the AI Ethics, Inclusion and Society MOOC's impact on second-year students' perceptions and behaviours. This presentation will discuss the AI Ethics MOOC, quantitative analysis of the MOOC survey dataset, qualitative analysis of the ITU dataset, and an interpretation of these findings combined. What is the MOOC? The MOOC, or Massive Open Online Course, is a 3-week course co-designed by students to develop an accessible online course for anybody interested in AI. It contains videos, articles, interviews, and reflective activities to engage learners, and it was designed for anyone who is curious about AI ethics, bias, inclusion, and society. The MOOC has gained 1,298 global learners, with 34,669 learning steps visited and 2,267 discussion posts in the comments. Of this, 95% of learners said the MOOC met or exceeded their expectations, and 90% reported gaining new knowledge and skills from it.
Before and after completion of the MOOC, students received identical surveys. The surveys consisted of 10 Likert statements with a 5-point scale from strongly disagree to strongly agree. Quantitative analyses included descriptive statistics in Excel, which included frequency, percentages, and visualization using bar charts. Distributional analysis, which included median, quartile, and interquartile range, and inferential analysis, which included Mann-Whitney U-test and effect sizes in SPSS. This slide represents the results obtained from descriptive statistics. These 10 statements are ranked by magnitude of change post-MOOC in overall agreement. Environmental awareness showed its biggest change from 74% to 86%. Confidence in AI increased by 7%, whereas concerns about data and data privacy actually decreased post-MOOC from 60% to 59%. For Statement 6, Environmental Awareness of AI, neutrality reduced 13 to 7% post-MOOC. Overall agreement increased by 12%, with strongly agreed increasing by 7% from 36 to 43%. Q1 increased from 3 to 4, which shows 25% of students moved from neutrality to agreement. IQR contracted from 2 to 1, showing that there was a greater consensus among students. Overall, these results demonstrate that there was a closure of a knowledge gap post-MOOC. For all 10 statements, P was greater than 0.05, therefore showing that the results were statistically non-significant. Furthermore, effect sizes for all statements were relatively small and less than 0.12. This shows that the magnitude difference between the pre and post groups were relatively small and therefore, again, not statistically significant. Statistically non-significant results may have been achieved for several reasons. First of all, as the responses to the surveys was anonymous, they could not be paired and therefore both groups were treated as being independent. And so a Mann-Whitney U-test, a central tendency non-parametric approach was used. It requires large separation between the groups to obtain statistically significant results. Furthermore, as the data was ordinal and majority of the shifts occurred within categories, for example, from going from agree to strongly agree, majority of the changes post-MOOC did not lead to changes in the median and therefore were not picked up by the Mann-Whitney U-test. Lastly, due to the current expansion of AI, majority of students pre-MOOC already had a high baseline awareness and familiarization with AI. This created a ceiling effect and led to minimum measurable upward movement. Overall, despite having statistically non-significant results, the MOOC did lead to changes in perceptions. It just led to a refinement in understanding rather than leading to major attitude shifts. To summarize the quantitative findings, the data reveals a clear and consistent pattern. Where students lacked prior knowledge, the MOOC created new cohort-wide understanding. Alongside this, pre-existing dispositions towards confident and ethical awareness were meaningfully strengthened post-MOOC. However, the data is equally clear about the limitations. Broad ideological positions regarding AI's societal role show negligible distributional shifts, and deeply consolidated attitudes around privacy proved largely resistant to change, with one statement showing increased polarization post-intervention rather than convergence. Taken together, these findings suggest that the MOOC was effective at filling knowledge gaps and consolidating emerging views, but was unlikely to challenge macro-level worldviews or culturally embedded views.
With qualitative analysis, the data was taken from reflective paragraphs from the second-year chemistry students' ITU assessment. The ITU is a mandatory 2-day course to help with students' academic writing. They are required to write an essay as part of this course, and in that essay were asked at the end to discuss their uses of AI. The data was collected by a member of staff who emailed all participating students from 2023, 2024, and 2025 in an opt-in basis. This data was then pseudo-anonymized and accessed for thematic analysis in the software in vivo. Thematic analysis revealed that the use of AI for referencing declined over time to the point it was completely absent from the 2025 cohort, reflecting a greater awareness of the issues surrounding AI, likely expedited by the MOOC. It also showed that the use of AI as a tutor increased from 2023 to 2024, but decreased in 2025, likely suggesting that the students became more cautious of their AI use because of the MOOC. Analysis also showed an increase in the concern students had about AI, most frequently in the 2025 cohort, which may reflect the influence the MOOC had. These suggest that the MOOC may have encouraged more critical engagement with AI. Looking at data relating more to temporal changes, overall AI use increased from 2023 to 2024, which suggests an increasing familiarity with generative AI tools. It also showed decline in some specific areas, possibly reflecting students' increasing awareness of issues AI has. Students over time expressed more and more concerns about AI and its accuracy, over-reliance issues, and academic integrity risks. All of these changes likely reflect the growing awareness of benefits and limitations of AI. Overall, students showed increased awareness of AI limitations and more cautious use of AI, both over time and with introduction of the MOOC. However, some themes didn't have consistent changes and indicate no clear trend that could be attributed to temporal changes or the MOOC. Also, some changes are related to the change over time and do not indicate any influence from the MOOC. Overall, despite inferential statistics producing non-significant results, the descriptive and distributional trends showed that the MOOC led to a refinement of students' understanding rather than leading to major attitude changes, with the biggest change in students' perceptions being in areas where students had a knowledge gap. As the MOOC is a short-term intervention, attitudes that are more broadly affected by society and culture were not affected and remained relatively stable pre- versus post-MOOC. The thematic analysis results suggested the MOOC has contributed to more critical and cautious use of AI among students. And overall, both projects conclude that the AI ethics MOOC is effective as an educational intervention for second-year chemistry students.